In this video, we're going to talk about a few more details that you might want to know about threads. The first one we're going to talk about is deadlock. So sometimes it's possible that two threads might need to acquire locks on the same objects. And that could result in something called deadlock, in which each thread has a lock on one of the objects and is waiting for the lock on the other object. So consider this scenario with two threads and two objects. Thread 1 acquired a lock on object 1. Thread 2 gets a lock on object 2. Thread 1 is now waiting for the lock on object 2, and thread 2 is waiting for the lock on object 1. So they're both waiting on the other one to release its locks. But since they're both waiting, nothing's ever going to happen, and they are in deadlock. Because both threads are waiting for the other one to release in order to get the lock, neither one of them can run. It's a dangerous condition. We don't want that to happen in our programs. How do you fix it? Read this very carefully and read it over and over again till you get it. So deadlock can be easily avoided by using a simple technique known as resource ordering. With this technique, you assign an order to all the objects whose locks must be acquired and ensure that each thread acquires the locks in that order. Okay. So for example, suppose the objects are ordered as object 1 and object 2. Using the resource ordering technique, thread 2 must get its lock on object 1 first and then object 2, which was not what happened in the previous example. Thread 1 got object 1, thread 2 got object 2, and they were both waiting on each other. Okay. So thread 2 has to acquire object 1 and then object 2. And then once thread 1 acquires a lock on object 1, thread 2 will have to wait for it because it's forced to get object 1 first, and because thread 1 has it, it can't do it. So thread 2 has to wait for the lock on object 1. So thread 1 will be able to acquire a lock on object 2. So both threads are required to get the locks in the same order, and that prevents deadlock. One more detail, thread states. We've talked about a lot of these thread states. This is a nice little diagram to show you the states of a thread as it's running. So when we create a new thread, we call start, it goes into the ready state. When we call run, it calls the run method and it goes into its running state. When run is finished, it will go into the finish state. But remember, we have methods that we can run on our threads. So while they're running, if we call join, it's going to go down here and go into a wait mode and wait for the target to get finished while that other thread runs. Once that target gets finished, it'll go back to ready and start running. If we call the yield method on a running thread, it'll go back to the ready state, giving the other threads a chance to run, and then it'll go back to its run state when it can. When we call sleep, we tell it to sleep for a certain number of milliseconds. It waits for a certain timeout, reverts back to its ready state, and then tries to run again. And when we call wait, actually that should be await. We just saw that in the previous video. It sits and waits to be notified till it's signaled by the lock, by the condition associated with the lock. When it's complete, it gets the signal, it goes back to the ready state, and then runs again. And this cycle can complete and constantly run and go different ways depending on what we're doing. But ultimately it starts, it runs, and it finishes unless we call one of these other methods. So that's a nice diagram to try and visualize the different states that can happen with a thread. And the last thing I'm going to talk about is synchronized collections. So we spent quite a bit of time looking at different collections in Java, and they are extremely useful. All the different collections, lists and maps and sets and sorted maps and sorted sets. Extremely useful things, but the thing you need to know about the Java collections framework is that they're not thread safe. When you start using collections with threads, you can have issues. if they can be corrupted if they're accessed and updated concurrently by multiple threads. So they are not thread safe objects. But you can protect the data in a collection by locking the collection or using a synchronized collection. So there are 6 static methods for wrapping a collection into a synchronized version. A collection is created using these methods are called synchronized wrappers. So we can call synchronized collection and pass it a collection to get a generic collection. And it exists for all these. So if we have a set we want to use, we can wrap it in a synchronized set and create a set that is thread safe. So I'm not going to go into how to do that. The book doesn't go into how to do that explicitly. But it's important that you understand that if you're using a collection and it's a shared resource, it is not thread safe unless you wrap it in one of these synchronization wrappers. And then you can use it with threading.